Before starting the inventory control, we should define the inventory. An inventory can be defined as a stock of goods which is held for the purpose of future production or sales. The stock of goods may be kept in the following forms, that is the raw materials, partially finished item, finished goods and spare parts. Now inventory problem. An inventory problem exists of amount of goods in stock is subject to control if there is at least one cost that decreases as inventory increases. Now, classification of inventory models. The inventory problem may be classified into two categories. First is the deterministic model and second is the probabilistic model. Deterministic model. In deterministic model, the demand is known and is fixed for the subsequent period of time. Now, economic lot size formula. The inventory problem in which the demand is assumed to be fixed and completely predetermined are known as the economic lot size problem or economic order quantity, a sort that is the EOQ. Economic order quantity. Economic order quantity is that size of order which minimize the total cost that include carrying cost and the shortage cost under the assumption that the demand is fixed and known. Now, we should determine the model second, economic lot size model with rate of demand in different production cycle, infinite production rate and having no shortage. To derive an economic lot size formula and the minimum average cost under the same assumption as in model, first we accept that the demand rates are different in different production cycle. Its solution is, let's Q be the unit of quantity produced per production run. Then we should understand from this following figure where Q is the inventory and T is the total time. Now, if R is the total demand in total period T, then the number of production cycle it is equal to R by Q, it is equal to N. Say, since shortage are not allowed, let T1, T2, T3 and Tn be the time of successive production cycles such that T is equal to T1 plus T2 plus T3 plus Tn. Now we can solve this by following. Now the cost of holding inventory. For the period T, it is equal to C1 and sum of area of n triangle in the figure 1. Now it is equal to C1 and sum of area of n triangle, that is the half Q T1 plus half Q T2 plus half Q T3 plus dash half Q Tn. Now from this figure the area of n triangle is half Q T1. Now it is equal to C1 and half given Q is common, that is half Q and T1 plus T2 plus T3 plus dash Tn. Now it is equal to half Q C1 T. Now the cost of setup. Now the setup cost, it is equal to MC3, it is equal to R by Q C3. Now the total cost for the period T. Now the total cost for period t, it is equal to the cost of holding plus the setup cost, that is the 1 by 2 q c1t plus r by q c3. Now the average total cost average total cost per unit time CQ, that is CQ, it is equal to, it is we differentiating dividing by t, we had the total average cost, that is the 1 by 2 q c1 plus r t q c3. Now let it is the equation 2, and for minimum value of CQ, minimum value of CQ, that is differentiating above with respect to Q, that is the dq dc by dq, it is equal to half q c1, half c, that is the half c1 and minus r c3 by t q square. Let half c1 minus r c3 by t q square, it is equal to, then we have q, it is equal to q star, it is equal to under root 2 r c3 by c1 t. Now hence equation 3. Now CQ given by 2 as minimum for the value of Q is given by equation 3. Hence equation 3 gives the required economic lot size formula. From equation 2, the minimum cost per unit time. From equation 2, the minimum cost per unit time is given by C minimum, it is equal to half C1, that is a Q, and the value of Q is 2RC3 by C1T plus RC3 by T, and the value of Q, that is a 2RC3 by C1T. Now C minimum, it is equal to under root C1 C3 R by 2T plus under root C1 C3 R by 2T, that is C minimum, it is equal to under root 2 C1 C3 R by T. That's complete my topic. Thank you.